Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone. So today let's continue our discussion on 10 questions on rotational motion, in which we'll discuss moment of inertia, torque, angular momentum, also angular speed. Okay, so welcome to this session of 10 questions on physics for NEET examination, and you can download our app Bohdi Park NEET and J Academy, and the link is given in the description. So let's start. With this first question. Question number 1. A thin circular ring of mass capital M radius r rotating about its axis with constant angular velocity omega. So there is a ring. So suppose this is a ring and this is the axis, mass is m, radius is r. Now it is rotating with angular velocity omega about this axis. It is rotating. 4 objects each of mass m are kept gently. Gently means we can say there is no external torque. Gently to the opposite ends of the two perpendicular diameter. So this ring will have 4 masses like this: 1, 2, 3, 4. 4 masses, each of mass small m. So what is the new angular velocity? Suppose it is omega dash. So if you look from the top, the ring will be like this. So previously the ring is like this, and after 4 masses are placed, it will be like this. So this is the axis. About this axis, what is the moment of inertia? Mr square. So angular momentum conservation, because there is no external torque, no external torque. So when some object is gently put on the ring, so external torque is 0. So angular momentum is conserved. So mr square into omega is equal to new moment of inertia, which is mr square plus the moment of inertia of the 4 particles, which is 4 times of mr square. And this distance from the axis is r. So into omega dash. So I1 omega 1, basically we are using I1 omega 1 is equal to I2 omega 2. So we have r square cancel over here. So we get omega dash is equal to capital M into omega by capital M plus 4m. So that is first option. Now next question. In this question, what they are saying, the angular momentum of a system of particle is conserved. Conserved means remains same. So what is the condition that angular momentum remains same? So L initial is equal to L final. So this is possible when net torque is 0, because we know that torque is equal to dl by dt. Net torque is equal to dl by dt, and if L is constant, so dl by dt will be 0. So net torque is 0. Now net torque means internal torque plus external torque. Internal torque is always 0, because internal torques cancel each other, like internal forces cancel each other, so internal torques cancel each other for system of particles. So if there is no external torque also, then we can say net torque 0. So the angular momentum is conserved when no external torque acts on system. So that will be answer. Next, now look at this question. Two rigid bodies A and B rotate with rotational kinetic energies EA and EB. Okay. What is the formula for rotational kinetic energy? Half I omega square. And in terms of angular momentum, we can say angular momentum is equal to I omega. So if you multiply and divide by I, this will become I square omega square by 2I. So L square by 2I. So we have E is directly proportional to L square by I. Using this, we can say how to find ratio of angular momentum of A to angular momentum of B when you know the ratio of EA and EB and IA and IB. So use this. So we have L square is proportional to EI. So L is proportional to square root of EI. So LA by LB is equal to square root of EA by EB into IA by IB. Then EA by EB is 100 and IA by IB is 1 by 4. That will be equal to 10 by 2 or 5 by 1. C option. Next question. Look at this question. So over here, uniform heavy disk is rotating at constant angular velocity. Disk is rotating, okay, like a platform, circular platform. It is rotating with constant angular velocity about vertical axis through its center. So there is an axis, vertical axis, perpendicular to plane of the disk. L is angular momentum. Lump of plasticine is dropped vertically on the disk and stick to it. So whenever there is a disk rotating and some lump of plasticine or mud or any other thing comes and stick to it, so the external torque becomes 0. Only internal torques are there, and one torque will be on mud or lump, other torque will be on disk, and both are equal and opposite. So net internal torque is 0 and external torque is also 0. So we can conserve angular momentum. So angular momentum will be conserved, and we know that L is equal to I omega. So L will be conserved and I1 omega 1 will be equal to I2 omega 2, and omega will be inversely proportional to I. If moment of inertia is decreased, so omega will increase. If moment of inertia increased, so omega will decrease. Okay, done. So next question now. So for this question, two disks of moment of inertia I1, I2, angular velocities omega 1, omega 2, rotating along collinear axis. Collinear axis means both have same axis. So if we draw the diagram, they will look like this. Suppose this is the first disk and this is the second disk. First disk, second disk, both are like this. Okay, so they have the same axis passing through their center of mass and perpendicular to their plane. So axis is perpendicular to the plane. Now they are made to rotate combinedly along the same axis. What is the rotational kinetic energy of system now? So these type of questions, when one disk is placed over another disk, you have to conserve angular momentum. So previously these disks have a moment of inertia I1 and angular speeds omega 1 and omega 2. So we can say L initial is equal to L final. So I1 omega 1 plus I2 omega 2, this is L initial for the system. Okay. Now when these two disks are joined, their angular velocities will be same. Now these two disks are joined, so moment of inertia is I1 plus I2 and angular speed is omega dash. Common angular velocity after joining common angular velocities, correct? So we can say I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 into omega dash. So omega dash is equal to I1 omega 1 plus I2 omega 2 divided by I1 plus I2. So this is the common angular velocity. But the question is asking what is the rotational kinetic energy. So how to find that rotational kinetic energy? So rotational kinetic energy is half I omega square. So for system it is I1 plus I2, half I1 plus I2 into omega dash square. So I1 omega 1 plus I2 omega 2 by I1 plus I2 whole square. So this I1 plus I2 is cancelled and we'll get the third option. Clear? Now let's move on to sixth question. Now look at this new question, sixth question, which is a particle performs uniform circular motion. Uniform circular motion means speed constant with an angular momentum L. If frequency of particle is doubled, we know that frequency is F. So omega is equal to 2 pi F and angular momentum is I omega and I is equal to mr square and omega is 2 pi F. So basically L is equal to mr square into 2 pi F. Frequency double, kinetic energy halved. What is the new angular momentum? Let us write K is equal to half mv square. And angular momentum we can use mvr. So when kinetic energy is halved, halved means 1 by 2 times. So speed is 1 by root 2 times. Now L is proportional to V into R. So what is the effect on radius? So for radius they have not mentioned anything, only frequency they have mentioned, it is doubled. So frequency is equal to 1 upon time, and time is equal to 2 pi r by V, and frequency is doubled, so time is halved. So this is 1 by 2 times, and this is r, and this is V. V is 1 by root 2 times. So this root 2 will go numerator, then it will come here. So 1 by 2 root 2 times. Radius is becoming 1 by 2 root 2 times. So using this formula, we can say L is becoming V into R. That means 1 by root 2 into 1 by 2 root 2 times. So 1 by root 2 into 1 by 2 root 2, it is 1 by 4. Okay. So angular momentum will become 1 by 4 times. So we have this formula, kinetic energy half mv square, L is equal to mvr. Okay, done. So now next question. For the seventh question, calculate the angular momentum of a body whose rotational energy is 10 joule. Angular momentum vector coincides with the axis of rotation, and moment of inertia is 8 into 10 raised to minus 7. So suppose this is the body, you can assume it is a disc, and this is the axis. So suppose the axis is vertical and this object is rotating, and the plane of the disc is horizontal, it is rotating. So this is the axis. So angular momentum is also axial vector. L vector is axial vector about this point, about the center. Angular momentum about the center of the disc will be along axis. Clear? So we have kinetic energy is equal to L square divided by 2I. Let's use this formula. So we have to find angular momentum. So L will be equal to square root of 2ke into I. So square root of 2 into kinetic energy, which is 10 joule, into moment of inertia 8 into 10 raised to minus 7. That is equal to square root 16 into 10 raised to minus 6, or 4 into 10 raised to minus 3. So first option, and this is the unit kg meter square per second. Clear? Next question. An automobile engine develops 100 kilowatt power when rotating at a speed 1800 revolutions per minute. What torque does it deliver? Okay, so what is the relation between power, torque, and angular velocity? So if you remember translational motion, for translational motion, power is equal to force into velocity, instantaneous force into instantaneous velocity, all in instantaneous. And for rotational motion, power is equal to, now as you can see, we study force in translation motion. So what is the counterpart in rotational motion? Instead of force, what we study, it is torque. Instead of linear velocity, what we study in angular or rotational motion, angular speed. So torque into angular speed is equal to power. So we have to find torque. So torque is equal to power upon angular speed. So 100 into 10 raised to 3 divided by angular speed is given in revolution per minute, that is RPM. So let's convert that. So 1 revolution per minute is equal to 2 pi radian divided by 60 seconds, or pi by 30 radian per second. So 1800 revolution per minute means 1800 revolution per minute is equal to 1800 into pi by 30 radian per second, that is equal to 60 pi radian per second. 60 pi radian per second. So we'll put here 60 pi. So that is 10 raised to 4 by 6 pi. So if we find the approximate answer, we'll get it 10,000 divided by 6 into 3.14. It is close to 20. So close to 500. So now this number is less than 20. 6 into pi is less than 20. So this whole number will be more than 500. So C option. Next question. Again, this question is based on vectors. So we have a formula to calculate torque. That formula is torque vector is equal to R vector cross omega vector. This is one formula. Oh, sorry. Now, how to calculate torque when force is given and position vector of a point is given? So torque formula, torque is equal to R cross F, R vector cross F vector. R vector is position vector of point about or with respect to origin. So suppose this is the y-axis, this is x-axis, and at this point force is acting. Suppose the force is acting, okay, I will draw the two-dimensional diagram. Suppose force is acting at this point like this, and this is the position vector R vector. So about origin, what is the torque? So this is the formula R cross F. So we'll use the determinant method. So I, J, K, this is the first row, and second row will be the components of R vector, which is 7, 3, 1. And the third row will be the components of force vector, which is -3, 1 and 5. So when we solve this, we'll get I cap into 15 minus 1 minus j cap into 35 plus 3 plus k cap into 7 plus 9. So that is 14I minus 38j plus 16k. So first option, okay, that is for torque. Torque is equal to R cross F. Next question. Look at this question. Torque of 30 Newton meter is applied on a 5 kg wheel whose moment of inertia is 2 kg into meter square for 10 seconds. Angle covered by the wheel in 10 seconds. When you apply torque, the object rotates. For example, this is the object. If I apply torque, so it is rotating. It is rotating. Why? Because angular acceleration will be there, or you can look at the fan. If torque is applied, the fan rotates. If one round means 360 degree or 2 pi radian, half round means pi radian. So torque causes angular acceleration, and because of angular acceleration, angle is covered, theta. So what is given? Torque is given 30, so that is equal to I alpha, and I is given 2. So we got alpha is equal to 15 radian per second square. Time is given 10 seconds. The angle covered we have to find. So we can use the formula, the equation of motion. In linear or translation motion, we have S is equal to ut plus half at square. So for rotational motion, we have a formula, angle covered theta is equal to omega naught t plus half alpha t square. So omega naught is 0, initial angular velocity is 0. It is not clearly mentioned, but we have to assume it. So theta is equal to half into alpha into t square. So 7.5 into 100 or 750 radian. SI unit of angle is radian. So answer is in radian, 750 radian. Okay, that's all. Thank you.